Welcome to Don't Panic Geocacher, a channel devoted to helping you solve mystery geocaches. My name is Arjen, or I go by Waterfan5 on the geocaching.com website. And today's episode is all about the 2 mile radius. This is step 3 of a series of 10 that gives you kind of like a structural approach of how you can look at a mystery cache when you don't know what to solve it, kind of step by step, hopefully bring you a solution. So let's talk more about the 2 mile radius. 2 mile radius was introduced in 2006 and software wise enforced in 2010. If you find all the caches, they might be outside the 2 mile radius, but certainly anything posted after these dates will be in the 2 mile radius. And you can use that to your advantage when solving geocaches, as it gives you kind of like an idea of what can change. So let's take here an example coordinate. So, and in this coordinate, the first part is the degrees, and often wouldn't change unless we're in the really low or high numbers, right? So the low numbers would be the 00, the minutes for the second part, and the high would be 59 because it goes to 60. So that one can be off by as much as 2 and can even be off by 3, but often may only be off by 1 at the most. So you see here for this coordinate, 23, 24, 25, 26, 27 could all be valid coordinates and should be worth considering. The same for 15, 16, 17, which is the one we had, 18, 19. However, a lot of them don't fall within the 2 mile radius, and unless we closer analyze that, we may assume something is a valid solution because we think it's in the 2 mile radius, but it actually would. So for example, both off by 2 doesn't look like it's possible, but I will show you it's actually possible. Even 3 is possible. And the same if you go even off by 1, both off by 1, it looks like, oh, that must still be in a 2 mile radius, and it may not. So it's always good to take a look at the 2 mile radius. And so let's take a look a little bit deeper. So here is the example, but now with a graphical map. I will show this website a little bit more in a second. But here I've now drawn the grid, and you see posted coordinates 1 here in the middle, and you see all the valid scenarios. And based on where this is, you now see all the possible options. And typically there would be about 17 coordinate options that could give potential valid coordinates. But you see that even some of them are not valid. So let's take a more dynamic look and look at the software itself, the website itself, and take a look. Let's take a more visual look at the 2 mile radius. So I'm using Geocalc, listen to me website. It accepts the coordinates in many different formats using digital decimal format here, and see where it brings us. So in this case, out Little Rock, Arkansas. Okay. And so I can enter some alternatives. This is like posting coordinates. So that way you know that this is the posting coordinates. And I can enter a bearing and a distance. So typically bearing is for projections. I could say go into 100 degrees and it kind of will draw a line in that direction. Right? I could also do it a certain distance. So for example, say 2 miles. So or longer, 5 miles. But if I just want to see the 2 mile radius, I just fill in the distance and then I get a circle. This is the 2 mile radius. So if this is the posted coordinates, then my cache needs to be within this radius. Now you see it automatically converted. So this is from the decimal to standard GPS format. So this is 44 and 18. As I mentioned, typically 2 up, 2 down is where kind of the maximum, sometimes 3. So if I do show grid lines and have it recalculate, then it actually will show you this. This is my posted coordinates in 4418. So the one to the left is 4419, 4420. So you see kind of like we're at the edge of things. But they could even be both. See a tiny little sliver here at the top. Zoom that. We can see 46 and 20. So 2 up, 2 up. Right? But it's certainly not possible in every direction. There is not right here, it doesn't exist. It all depends on the beginning coordinates. So this will allow you to kind of verify, well, which numbers do I need to check? Do I need to take -3 into account? Yes or no? And so this allows you to kind of see which numbers do I need to take into account, which numbers can I safely. Sometimes both are two off, but sometimes even like if it's one off. So let's take this one. I'm here, I'm at 45 and 17. Both of them are only one off, but I'm still outside of the 2-mile radius, given that this was my posted coordinates, right? So this is important to take a look at, to see what's there. And now you may, for example, use other hints like, is it on a trail? Well, where is that trail? Or, for example, hey, there's a cemetery here. It hinted to a cemetery. Might be others, but I can take a look here and see what the posted coordinate is here. And that might give me a hint of what my partial coordinates would be. And maybe I'm able to reverse engineer the solution with this. So this is just one of the tools that you can use. The tool can do a lot more. I may do a special session about it. Another important element to consider is that within the 2-mile radius, some of the spaces may already be occupied by other geocaches. If it's a very rural area, of course, there might be very few caches there. But it's worth looking at the geocaching new cache placement place and kind of pretend you're placing a new cache in that area to see what areas are already being blocked out. You can also look up the location in Google Maps and see what would match kind of the terrain and the cache description. So for example, if you look for a very low terrain and that most of the area is all forest, or then it's like, okay, well, it could be next to a road. And so you look for somewhat there, or maybe you're looking near a store that might be out there. So try to, on the map, already draw the 2-mile radius again and see what falls in there. Where could it be? For example, does it mention a park? Say like, oh, entrance fee is required. Does it mention it's not on the cemetery? Well, most likely it will be near that cemetery. So take those into account and help already. That may help you try to figure out where the final will be. Because if you know even a partial final coordinate that is more defined than maybe just the posted coordinates, it again can help you solve the cache and the puzzle itself. So it kind of allows you to reason backwards by knowing some numbers. So for many mystery caches, this has helped me further into like, okay, this is what the answer could be. Now let's try and figure out if I can see a certain pattern now that I maybe know a lot more numbers, or I know that my numbers need to be somewhere around here. So let's take a look at an example. This one is called Crackity and Uncrackable. It's actually based on real mystery cache, but as I didn't create it, I didn't want to give away somebody else's answer. So I kind of remade the puzzle, put it in a different location. So in this case, it's I give you the fictional posted coordinates. Um, Puzzle cache page said that the degrees part were already a given, so we only need to look for the minutes. So we need to look for 10 digits. It was a 3-star and puzzle. So we're probably looking at something slightly more complicated than just a substitution. But as I gave in previous training and educational sessions, it doesn't hurt to kind of like adjust your thinking as well and go maybe start simpler and then go to the 3-star where we expect some kind of cipher. In this case, because it's only 3-star and not 4-star and 5-star, we're not expecting too many twists along the way, kind of expecting it to just be a cipher that causes the solution. So let's take a look at this more carefully, taking the 2-mile radius into account. So let's take a look at this puzzle. You know the posted coordinates, so 34 and 81 are given, so we're looking for 10 digits that are right here. It was called the Crackity and Uncrackable, so that is already a clear hint that we kind of like looking for a cipher, but it was also 3-star. And there is something called the Uncrackable cipher, which is a Vigenère cipher. So we're probably looking at that cipher, but it's called Uncrackable. Well, it's actually pretty crackable if you know what you're doing and if there's certain restrictions like both the key and the result are supposed to be English. And that's what a lot of crack tools work with. But let's see what our professionals say. So I'll take the text and bring it to our cipher identifier. This is another class as well. Oops. Put it here. And see what it says. And indeed, as a top one, it gives that Virginia cipher, uncrackable cipher. Other ones are actually variations of those. So one-time pad is just another cipher, and it kind of work the same as a keyboard. It's just an alphabet. But you see that a simple substitution cipher, Caesar ciphers, they're not very likely in this scenario, based on the analysis. Okay, so let's try it. This website has a variety of cracking tools for it. So let's try and see what it does. Automatic decryption. And say, let's crack it. None of that looks really English to me. That's a bummer. Well, maybe if we say it starts with a 2, right? So, crypt starts with a 2. Still nothing. You see, finds 2, but nothing comes out of this. So, yeah, cracking tools are great, but certainly have their limitations. There are ones out there that will solve this one. But even this is one of the even better ones. But yeah, it doesn't solve it in this case. So we have to recite to something else because the title said, well, we're really looking at a engineer site. So I'm going to use a different one, a different website in this case. It's called Crackity. And Crackity has the advantage that it works nice live. So I can put in code to decode, and I can put some text in here. And so decoding, and I need to put the text, my cipher text here. Now, Visioneer has the unique ability that if the key and the plain text are actually reversible, and we can use that to kind of crack it. So we can of course say, well, we need to find the word. So maybe the word is geocache. See, as I type, it immediately lives decoded, so makes it very nice for training purposes. Ground speak, and really it doesn't work. But if you noticed, every letter that I add changes one letter in the outcome at the beginning, right? So you can kind of follow where it goes, but the first part is not influenced by it. That we can utilize to actually crack the cipher because, well, given our starting chords 2, 5, because the 34 was given, kind of know, okay, it should be somewhere maybe in the 20 range, right? 21 to 27, 2-mile radius. So maybe it just starts with 20. That doesn't look very good at the beginning. So let's start with 2. Also doesn't look very good, but 2 is kind of short. So maybe we guess just 2 numbers, as mentioned, 21 to or 23 to 27. So let's try 23. Now that looks pretty much like garbage, right? We only have to look at the first part. So we can even turn the repeat off if we want it, but I'll leave it on for now. Yeah, that doesn't look good. So the 2-5 also heli doesn't look very good. Or looks better. Helicopter. It looks like a word to me. So now I can put helicopter here. And, well, it still doesn't decipher it, but let's type it out completely. And suddenly we see that we have completely decoded. And helicopter was a keyboard, and the puzzle is solved. 2, 4, 3, 8, 2, 7. All looks good. So even though the automatic crackers couldn't do it, because we knew that it had to be the 2-mile radius, we could just guess what the words could be. Sometimes you have to be very creative because puzzles, if there's longer text, then it might be, oh, it starts with the cache location is, congratulations, or you can find. So there's some common words that you can try, but the good thing is you can try them all as the key and then see if the answer makes sense. And this is often how those crackers work as well, right? They just try to see what gives them the most English, but since they don't really know that we're looking for coordinates, kind of limits them in their scope, making it more difficult. So yeah, so now we have cracked the uncrackable cipher. And this was just the summary of the solution. So we had this uncrackable cipher. At the end, the keyword ended up be and helicopter in the Vigenère cipher, and that gave us the coordinate. So even though it's often considered uncrackable, this is a good tool to use if you feel that you know what the answer might be, or experiment with different answers and quickly see results. Let's take another one. I called this one guessing, again based on a real puzzle out there, but I just changed it here. This presentation, so it's nowhere close to the actual puzzle cache. We see a bunch of numbers, and it's 2.5 star, and so yeah, this is it. This is what we have to do, right? So let's see and take a look how we can solve this and use 2 mile radius to our benefit. So 2 pieces we know is the posted coordinates and this long string of numbers. So we'll try our usual suspects first. So we'll try it with some common websites and to cipher identifier, see if it comes up with something. Mayan, Roman numerals, like it, random numbers, number geolocation. Okay, useful, don't know. And it gets some more, but nothing really that common, right? It doesn't look like it's a cipher at this point. Let's take a look at another website, Geocaching Toolbox. It has some text functions that might be useful. Let's try 2. In this case, actually 3. Let's do 3. And we're going to run it through those. So first, the base conversion to ASCII. Mentioned the previous conversion, we were using 10-digit number, 0 to 9, but you can also 4-digit, 8-digit, commonly used in puzzles. 2-1 is called binary, and we convert basically everything to zeros, ones. Okay, yeah, it's great, works, but it doesn't really at this point. It might be that this is the right track, but I don't have enough to see that. But it may be something worth considering. Potentially, this is the puzzle. This one has a lot of other conversions, but if we go to the higher digits, really becomes tricky. Maybe hex, it spells out something back. So we have to kind of the other way around. We can say from hex, now we go back to text and see if that gives us anything, any result. But it doesn't really show anything at this point. So I'm not sure if this is going to be a track. So let's try the next one. And this is just to reverse. Maybe in reverse it will look better, right? So we have this and take it into reverse. Well, I see something here. I see 62 and 62 here. At least the same number is used twice. I always like if there is beats in the text itself. That always looks good. Again, it's a very useful tool, verse and things with text manipulation, but in this case, really doesn't seem to help. And let's go to the next quick scan. Let's do text analysis, throw it in there, and take a look. So this counts words, characters, all things that might be useful. As you maybe remember from a previous one, it's always good to find numbers that you like. So in this case, 28 is actually a number that I like because a coordinate, as I mentioned in previous lessons, it has 14 digits. 28 is 2 times 14. That might be onto something. There's another thing here that I like, and that is that 0, 5, and 3 don't seem to be used. That seems a very odd division, that not all the numbers are used equally. 6 is used a lot. 2 is used a lot. So sometimes that might mean if you have a lot of 2s and 1s, that it's an alphabet encoding, right? Because the alphabet goes to 26, you have to use a lot of 1s and 2s to encode letters, but not enough. But I do like this part. 28. So how about we split it up into pairs of 2 and see where that leads us. So I'll create a quick table. So we need 14 digits, right? And don't know how many rows I need. So 6 rows for now. Shrink the text a little bit just to make sure it all fits. And let's split this text in pieces of 2. So take this text and paste it in there. Okay, that's good. So we have split it in 2. Now let's look at the original. Because if everyone represents a letter, let's just assume that this then needs to be a 3. This needs to be a 3. This needs to be a 4 or 5. This one I don't know, because that would be a 0, so it could be anywhere from an 8, 9, 0, 1, 2. So it's about half of them can be valid. Next 3, of course, can't guess at this point. So put question marks in here. This would now start representing the 8. This would be the 5. This would be 0. Now that one can't change because if I go from 0, 1 to 0, 5, remember 2 up, 2 down, I stay in the 0. This one stays a 0. This is anywhere from that 1 to 5. And then the next 3, I don't know. Question marks there. Now, I made the assumption that everything that was the same would be the same number. So let's continue that and just give them all like a letter. So 17 is an A, 68, I don't know. So that would first one I don't know. So that's a B. 24, next one I don't know is a C. 68, 68, yes, I have 68 here, so that is a B. I have 68 already here. And then 46, I have 46 here, that is a 5. And then this is of course the 8 and the 5 and the 0, which we knew. 24, it's the same as this one, so it'll be a C. 42, we don't know, so it's a D. 26, yep, that was a 3. And 21, I don't have 21 yet, so that is E. So we have 5 numbers that we really don't know. It's not bad. We have, out of the 14, we only have 5 that we don't know. So we're doing pretty good. Let's take a look at the 2-mile radius one more time, right? Because this needed to be a 4 or a 5. Well, I've already used a 5 here. Could be that this is also a 5, because we have the same here with different numbers. But this one actually looks quite similar, 2, 6 and 6, 2. This one, 1, 7, is very different than 4, 6. So I don't like that this one would also be a 5, so I'm going to call it a 4. So 3, 3, 3. Call this one a 4. And well, if it's a 4, it needs to be 9 or 8. Already used an 8. 68, 79. Doesn't look very similar, so I'm going to call this one that this one needs to be a 9. Because it can't be an 8. And then use the same here. So now C, this one needs to be a 9. 5, 8, 5, 0. The C and the D we still don't know, of course. And the 3 also stays the same. But we now actually have already a pretty decent starting point. And we've actually reduced it to that we only have now 3. C, D, and E. We got rid of A and B. So we're down to 3. Great. So let's keep doing that. Let's take a look at it again, right? So now we took the assumption that, well, this might be the reason here that they're the same is because they're swapped. We actually see that here at the beginning as well. We see 12 and 21. What if those are the same numbers? What about if 24 and 42 are actually the same? So, because that would match what we see here. So, okay, let's do that. Let's copy these around. Since these are the same, we now say, okay, C, so that now it means that this D becomes also a C, and 21 is the same as 12, 0. Okay, that looks pretty good. So we now have only one, the C, left. So C could initially 1 to 5. However, 5 we already used, 4 we already used, 3 we already used. So really it can only be a 1 or a 2. So that leaves us 2 coordinates to try. So that would be 9.195 west 850.1.10. That 1. And the other one would be somewhat similar. This one, but now instead of a 1, 2, 2, 2, right? All the C's now become 2. Okay, so let's take a look. I'll take this one as well and put that in the equation. So we now have 3 coordinates. Let's take a look where they are on the map. So we use our tool here, paste the numbers in there. Note I pasted all 3 at the same time. It will automatically split them then over 3 points. That's kind of nice. And we say the 2-mile radius, right? So we say distance 2 miles. This is point 1, that was the starting chord. start. So now it's a starting code, and this is 0.3, is 2, right? Well, you can very clearly see 0.2 is not within the 2-mile radius. This cannot be the answer with the new rules. This has to be the answer. And so now we know that this number, 0.3, which is the ones with a 2, needs to be the right answer. So at the end, we know that C needs to be 2. And now we have something that we can use checker. We don't know what the puzzle was, but we actually have solved it by just taking the 2 ideas into it. So even though we had solved the cache, we really didn't have the solution yet, because we had, of course, the answer, the coordinates, but what was the puzzle? Well, we had to break them into 2 pieces of 14, and we got all these individual numbers, and at the end, the guess that the order didn't matter actually turned out correct. So 26 and 62 is correct. Now take a look at the numeric keyboard, part of a keyboard, and you see here 2 and 6. Get to 2 to 6, you have to go over 3, and that was 3. 1 and 7, you have to go over 4, and the answer was 4. And so that's why the direction didn't matter, because really you could go in any way. Get a 5, you can go from 9 to 1, or from 1 to 9 to 6 if you want. So they could have made the puzzle slightly more complicated by 28, for example, for the 5, and now it's much harder to guess, because now 28 and 46 and 91 all would then go to 5, making the 5 very hard. But that wasn't done in this case, and so now we were able to crack it. Even though we didn't know that this was really the puzzle, we were still able to solve the solution, get to a green geochecker, and find the answer to this puzzle. So that brings me to the end of the presentation. As usual, here are the links that I used, some of the common ones that pretty much always are used, and then some specific here, like the Crypty one. Another one to make a look at if you just want to count letters. There's a specific website out there called Letter Count. Just count letters, maybe good for analysis as well. Worth taking a look at. With that, I reached the end of the presentation. If you enjoyed it, please upvote it, please press like. If you would like to stay informed, and when new presentations drop, you can click the subscribe button. That way you will get notified and stay up to date when the next one in this series drop. You can also leave a comment, say whether it was helpful, maybe detected something that was wrong. So please let me know. And if you have any questions or suggestions about other topics, puzzles you would like me to do, maybe you would like me to make a video about one of your puzzles, more than happy to do that. Use it as an example in one of the videos. You can contact me as WhatIfN5 on the geocaching.com website, or you can email me at geocacher.whatifn5@gmail.com. With that, I'll reach the end, and hopefully this presentation will stop you from panicking the next time you see a mystery cache. Thank you.